The product of powers rules. Again, dealing with exponential expressions. When a product is raised to a power, raise each factor to that power. So where I have a product inside parentheses here, multiplication problem, product, A and B being factors, raise each factor A and B to the power. Now please, please, please note, this is a product. It says nothing about a sum. Do not try this. If it's a sum, it will not work. It works only with products. But if you've got a product raised to a power, simply raise each factor to that power. So for instance, simplify negative 5x to the third power. Because I have parentheses and the exponent is sitting on the parentheses, this is a product to a power. Because inside parentheses, I have a product. So I'm going to raise each part of that product, each factor, to the power. Now, I do have to simplify. Negative 5 times negative 5 is positive 25. Times negative 5 is negative 125. So for my final answer, I get negative 125 x cubed. Raising each factor to the power. For our second example, things get a little bit more dicey. You got this negative sitting out front. Then you've got parentheses to a power. The power is only touching the parentheses. It is not touching that negative. So that negative is going to be in our answer. Now, I know that in elementary school, many of you went through and you said, oh, every time it's an even power, you're going to get a positive answer. That is true if you have an even number of negatives. But that power does not touch that negative, so I do not have an even number of negatives. I have 1. Hence, the negative will be a part of the answer. Then both of the factors that are inside the parentheses, that are touched by the parentheses, will get the power. So I'm going to end up with negative 3 to the 4th is 81 x to the 4th. Now I have students all the time ask me, Miss Harrell, if I miss that negative, do I miss the problem? The answer is yes. Yes, you do. A negative 81 and a positive 81 are not the same thing. Just like having $81 and owing $81 is not the same thing. You must be very, very careful with those signs. Okay. Final example for this slide. Looks confusing because I've got a fraction, but what I see is that I have a product right here, negative 3x squared y to the 5th, raised to the power 3. Then after I get through with that, I worry about that divided by 6. So let's take each factor and give him the power. So there's the negative 3 x squared and y to the 5th. And that denominator 6, he's just hanging on for dear life right now. So negative 3 times negative 3 is positive 9, times negative 3 is negative 27. When you raise a power to a power, you multiply the powers. See how all of these are going to come back to haunt you if you didn't learn them well. And again, for the y, when you raise a power to a power, you multiply the powers. So that's where the 6 and the 15 are coming to. Now, if I wanted to be a really ugly math teacher, I would give you a multiple choice test, and this would be one of the answers, and it would be incorrect. Why would it be incorrect? Because the directions at the top of the test, always, whether they're stated or simply implied, are to leave all answers in simplest form. This is not simplest form because 27 and 6 have a 3 in common. So if you divide a 3 out of the 27, you get 9. X to the 6th and y to the 15th are not bothered by that at all. And if you divide the same 3 out of the 6, you have 2 left. So this is my final answer. Again, yes, these problems are going to get very deep and very complicated very fast. So you need to practice each individual rule until you're really, really good at it so that you can then follow along when we get to the more challenging problems. So again, stop right here, practice as many of these as you need to until you get really good at it. Good luck. See you soon.